We were in the middle of almost done with proteins, so let's review proteins. And then as you are studying each of these nutrients, I want you to be able to associate them with their main function. Proteins, other than water, are our number one nutrient. And that is because they build and repair body tissues, and they are important functioning molecules. So each of these nutrients, what are they? Why are they important? Okay, how much should, I'm not going to ask you about daily requirements because they change every other week, okay? Except for water I might, but the others not so much. So the question I want to know, if you answered correctly just a minute ago, is what are proteins? What are proteins? The answer is?
Complex macromolecules composed of amino acids.
Okay, get partly there. The word is polypeptides, which are complex macromolecules. They consist of a chain of amino acids that folds into a particular shape so the protein can function. Polypeptide is the word. Proteins are polypeptides. Polypeptides is the name. That means they're a sequence, a very specific sequence of amino acids that fold on each other into a complex shape. And that's how the protein will function, is by its shape. A lot of times it's very globular. Then there are 20 different amino acids, 9 of which are essential. We talked about the two importance. What are proteins? Why are they important? They're the main structural component of the body. Talked about or mentioned collagen, elastin, etc. And they are important functioning molecules in the body. Enzymes, hormones, your blood proteins are all good examples. I mentioned epinephrine, that's a hormone, it's protein. Thyroxine controls your thyroid, that's a protein, it's a hormone. Mentioned insulin, that controls your blood sugar, that is a protein. Then I mentioned hemoglobin, that is a protein. The immunoglobulins, or the antibodies we talked about in immunity, those are proteins. And even the complement cascade in the chemical warfare of your innate immunity, those are proteins. So there are many, many important functioning molecules that are proteins. We left off with sources. There are two types of proteins: complete proteins and incomplete. What do you think that means? Complete is going to give us those 9 essential amino acids. Complete proteins will give us adequate amounts of the 9 essential amino acids. These would be what are called red meats. Red meat is beef, primarily, also pork. And of course, if you eat game meats, those are considered red meats. Poultry is in its own category. Fish, many dairy products, and also eggs will supply all 9 essential amino acids, so they're referred to as complete proteins. Incomplete proteins lack several of those essential amino acids. Incomplete proteins must be ingested in pairs so that you do get your 9 essential amino acids. Okay, so, and these are proteins that are plant products. Your other complete proteins are animal products. So incomplete proteins include leafy green vegetables, grains, those have some protein, but then the best source as far as plants are concerned are your legumes. Legumes. That's fancy for beans and peas and all their relatives, okay? All your beans and peas. Supply incomplete protein. Recommendations vary. Like I said, week to week, dietary recommendations change frequently, but it usually sits around 12 to 15% of your calorie intake. That means most women should be eating around 46 grams a day. Men a little more than that, 56 to 60 grams. And of course, pretty much you're going to get around 7 to 8 grams of protein per ounce of food that you eat. Vegetarians often do not get enough protein, and that's of course why they will usually eat rice and beans. Yes?
Could you repeat that? It was how many grams?
You get about 7 or 8 grams of protein per ounce of meat that you eat or dairy product that you consume. That's how many grams per ounce. So if you're eating about 8 grams, you're already getting your recommendations. Don't worry, we are fulfilling our recommendations, most of us, all the time, if not exceeding them. All right, that's it for proteins. Next is carbohydrates. What are carbohydrates? It's going to be the first question. Carbohydrates. Before we get into details, I want you to associate carbohydrates with energy. Energy, you probably know that. Carbohydrates are the primary energy sources. So, my question today will be, what are carbohydrates? The answer is sugars and starches called saccharides. So, carbohydrate. They are sugars and starches. Sugar is a big category in chemistry. It's not just the table sugar that you think of. Sugar, starches of all kinds, and they're called saccharides, spelled with a H. Okay, saccharides. The dietary carbohydrates that we're concerned with are sugars and starches. There's all kinds of carbohydrates, but we're dealing with dietary carbohydrates. They're all of your sugars, your starches. They're called saccharides. In fact, we divide them into monosaccharides, disaccharides, and polysaccharides. So carbohydrates, dietary carbohydrates are sugars and starches called saccharides. All right, your simple sugars would be the monosaccharides. A simple sugar, these simple sugars become the building blocks of the more complex carbohydrates. So your monosaccharides are your building blocks. Just like the amino acids are the building blocks of proteins, your monosaccharides are the building blocks of your other. Disaccharides, 2 of them. 2 monosaccharides linked together to form 1 molecule. Polysaccharides are long polymers, many repeating long chains of monosaccharides. Your monosaccharides, there are 3 of them. The first one is one you need to be familiar with. It is called glucose. This is a simple 6-carbon sugar. Now, if you look at the name, it says carbohydrate. And most of your dietary carbohydrates are going to be in a ratio of, if you think, this is glucose, C6H12O6. They're in if we reduce this, we're in a ratio of 1 carbon for every 2 hydrogens and 1 oxygen. Do you see why it's called a carbohydrate? What do you see in that? I see C and I see H2O. That's where the name comes from, hydrates of carbon. Because this is the water ratio, isn't it? So our carbohydrates that we're talking about, dietary carbohydrates, are saccharides. Monosaccharides, disaccharides, and polysaccharides. Glucose is a 6-carbon sugar. It is a monosaccharide, and it is the primary energy source for your cells. Energy source, it's right here. And so when you eat carbohydrates, your body's going to break them down to glucose, or if they're not made of glucose specifically, your body's going to convert them to glucose. And this is what circulates in your blood, commonly called blood sugar. It's glucose. So that is a very important monosaccharide. You need to know that by name. It is the energy source of the cell. In fact, we mentioned insulin. Insulin is a protein. It's a hormone. Insulin is the mediator that allows your body cells to take glucose out of your blood and use it. So when you have an insulin problem, your cells cannot uptake your glucose, and so your blood sugar gets higher and higher and higher, and you're having problems with energy and so forth. Of course, we call that diabetes. The other two monosaccharides are fructose and galactose. Fructose, you're going to notice the endings are all the same. Galactose. Fructose is a simple sugar commonly found in, look at the word, fruits. Okay. Galactose is also a simple sugar. It's found in dairy. Then your disaccharides are composed of a combination of two of these. These are with your disaccharides, for example, we have sucrose. I'll put the disaccharide, these are the monos. The disaccharides, sucrose, so-called table sugar. Only one of many, many, many kinds of sugar. This is a glucose and a fructose linked together. And it's called the disaccharide because it's two. Sucrose, table sugar. However, the table sugar that gets on our tables is highly refined and also bleached. It shouldn't be white, should it? Not naturally occurring, it wouldn't be. Then lactose. Anybody recognize lactose? That's commonly called milk sugar. It's a glucose and a galactose together form lactose, found in dairy. Then there's maltose. This is found in cereals. It's 2-glucose. So we're kind of more familiar with our disaccharides. Then polysaccharides are called complex. You've heard the term complex carbohydrates because they're long chains of many, many, many monosaccharides or simple sugars. Polysaccharides, referred to dietarily as complex carbohydrates. These are many, many long chains, particularly of glucose. There are 3 kinds of these. The first kind is starch. Starch. Starch is long chains of glucose. It is the molecule of plant carbohydrate storage. You see, when your body processes carbohydrates, we're going to convert to glucose so we can use it for energy. But what do you think happens if we have too much glucose? Our liver is going to take it out of the blood and store it. Store it first as glycogen. Glycogen. Glycogen is commonly called animal starch. This is the carbohydrate storage molecule that your body will go to first, also animals. This is called glycogen. It is the first area that your body will store extra carbohydrates. But then next step, if we have too much carbohydrate, then your liver will convert it to its lipid form and permanently, well, not permanently, but semi-permanently store it as fat. Okay, and this is all done by your liver. Liver's very good at converting different molecules into different forms for use or for storage. But glycogen is the first stage of carbohydrate storage. The last is called cellulose. Another complex carbohydrate. Cellulose is the plant cell walls or fiber. This is dietary fiber. It's a carbohydrate. So cellulose is commonly referred to as fiber or roughage, consisting mostly of your plant cell walls that your body cannot break down. Okay? So it will pass through your digestive tract, which keeps things healthy in there. So what are carbohydrates? They're sugars and starches called saccharides. Monosaccharides, these are your building blocks. Right here, monosaccharides, the glucose, the fructose, the galactose. Then your other sugars, disaccharide combinations of 2. Polysaccharides are the complex carbohydrates. Importance of dietary carbohydrates. Yes?
The maltose, what was that linked?
Two glucose molecules linked. It's commonly called malt sugar. It's from cereals and grains. It's 2 glucose. All right, the importance already mentioned. Number 1 importance is energy. Remember, at the beginning, before we started going into each nutrient, I said there are 3 uses of nutrients in the body. You must know them. Energy, right? Body maintenance and repair, and then proper cell function. So carbohydrates are involved in the energy aspect. So number 1 importance is energy. Why does the body need energy? What would be subpoints there? Why does the body need energy? Yes? Body heat. Remember, you are homeothermic. Your metabolism, of course that involves all those chemical reactions about how food is processed and how food is used, will keep your body temperature in a very small range. Average, of course, you know, is 98.6. That's average. People vary on either side of it. So, maintain body heat. Then, another reason we need energy is body movement. Remember, we did this the other day. Both internal functioning movements and external actual body movement that we think of when we say movement. So we need it for heat, we need it for movement, both our internal functioning movements and our external body part movements. And then last, we need energy for individual cellular functions. Everything requires energy. All of your cells have to take in glucose, not just your muscle cells or your main functioning cells. All of your cells must take in glucose and they use it for energy. A second thing with carbohydrates, there are some structural carbohydrates and they're usually attached to a protein. But we don't really think of carbohydrates in nutrition as being structural components. That's mostly protein. So carbohydrates, energy, glucose is the energy source for all of your body cells. Glucose is the most important simple sugar or monosaccharide. Sources of carbohydrates. Plant sources are your primary source. Starches come from vegetables and grain. Your starch you will get from vegetables. When I say starch, you probably all think potatoes. Okay, that's because the potato is where that potato plant stores its extra glucose in the form of starch. Also other vegetables, not just potatoes. But then grains provide a lot of carbohydrates. However, the problem with a lot of our grains is they're too highly processed. Breads and so forth, using bleached flour, using only part of the wheat instead of the whole wheat. So you're getting all these calories that have very little nutrition value, okay? The other problem with our bread is if you read it, you'll notice that they add extra gluten, a protein filler, and they also add one of your big enemies that I want you to know about, and that is high fructose corn syrup. Okay? That adds extra calories, that adds extra. I'm not sure why they put it in there. I think probably because we are so used to eating things that are sweet. And so we expect our bread's not sweet. Well, it has that high fructose corn syrup in it, which is a sweetener. That's the only thing I can think of that they would use it for. So that is one thing that we're going to talk about, is things to avoid. And the first thing for you to avoid in your ingredients is high fructose corn syrup. Whoop. Why can't I spell syrup today? Whatever. How do you spell syrup? Somebody tell me, quick.
S-Y-R-U-P.
S-Y what?
R-U-P.
It didn't look right. Okay. Mental block spelling. High fructose corn syrup. Okay. Avoid it. It is a sweetener. It has no nutrition value. So what is your liver going to do with all this fructose? Convert it to glucose. But you have too much glucose already. So what's it going to do? First convert it to glycogen. Oh, I already got glycogen stored to the max, so it's going to convert it to fat and store it. Okay, so high fructose corn syrup has no nutrition value other than a sweetener, and it's in almost all the different bread brands. Avoid it. All it is empty calories. You've heard that term before, high fructose corn syrup. Okay, so starches and sugars, of course, are your plant sources. You want to eat fruits and vegetables for your carbohydrate source, and slow down on the breads, the potatoes, and my personal favorite that I have to slow down on, pasta. Okay, too many carbohydrates. And that is just exacerbated by high fructose corn syrup. It's in all kinds of things that you don't think of as being sweet. Okay. So plant sources, your starches are your vegetables and grains. Also potatoes is your main thing that you might think of. Pasta. And then sugars you're going to get from fruits and vegetables. Animal sources, you do get carbohydrates from dairy. Remember, we have galactose, and also, which is a monosaccharide, and lactose itself, a disaccharide. Okay, metabolism of glucose. The metabolism of glucose. Because this is the primary, I didn't talk about metabolism with proteins because proteins are processed in a very complex way and have so many different uses. But when we're talking about carbohydrates, we're talking about energy. So I can talk about the metabolism of glucose. Okay, so first thing to know is glucose is, again, the energy source of all of your cells. All right? And what that means is your cells burn glucose for energy. Your cells burn glucose for energy. It's called cellular respiration. Now, if I was an artist, I'd draw a little cell inhaling and exhaling. But that's not what cellular respiration means. Cellular respiration is the overall chemical processes by which each cell, it's the overall chemical processes by which each cell converts glucose into energy. Cellular respiration. This involves several complex sequences. The first thing it involves is glycolysis, breaking it down. Then it goes into what's called the Krebs cycle, and it's so forth. But we're not going to detail that. All it is it is the complex chemical process by which every cell breaks down glucose and converts it to energy. Here is the overall summary equation. This is only a summary. Nowhere shows you all these. It's very complex. Here it is. Here's glucose. C6, H12O6. When we burn it, we literally combine it with oxygen, which is burning in a chemical sense. So what we do is, you know, your cells need oxygen. Your cells are given oxygen by your red blood cells. Remember, hemoglobin combines with oxygen, carries it to wherever it's needed in the blood. This is glucose. And so each of your body cells will burn glucose. Burning means adding oxygen. And let me draw lots and lots of arrows here. Several chemical processes going on. And then finally at the end, we have leftovers. Our leftovers are carbon dioxide and water. Of course, we have to balance. So we have equal numbers of atoms on both sides. But cellular respiration, this is the summary equation. Glucose is burned by each and every cell of your body, so that means it combines with oxygen through complex chemical reactions, and eventually all that's left is carbon dioxide, which you know your body will exhale. It'll be dissolved in your blood, and it'll be exchanged in the lungs, and then leftover water. But what it doesn't show, let me go ahead and fix it. What I didn't show was this. We're going to get energy from it. So the whole purpose of breaking chemical bonds, when you break and form chemical bonds, it always involves energy. Exothermic reactions give off energy. Endothermic reactions require energy. So what happens here is your body will capture this energy in a very important molecule. It's called ATP. That stands for adenosine triphosphate. ATP. And what that is, it's a very high energy bond, and that energy will be captured in that molecule. Then that energy can be used throughout the cell for whatever the cell needs it for. So glucose is the primary energy source for all of your body cells. And so what your digestive system will do when it breaks down complex carbohydrates, when it breaks down even more simple carbohydrates, it's going to process them into glucose. Unless you have too much, then it's going to store it as glycogen and eventually convert to fat if need be. Recommendations, again, vary from week to week, but usually around 100 grams of carbohydrate per day. All of us are most likely exceeding that. Okay? So we have water, proteins, carbohydrates, and now dietary lipids. Remember, we had those 4 biomolecules: nucleic acids, proteins, carbohydrates, lipids. Those are huge categories, and they don't just involve nutrition and foods. They involve all kinds of things. So we're going to call these dietary lipids. And even I should probably call them dietary carbohydrates, but dietary lipids. With lipids, I want you to associate them with energy reserves. That's code for storage, okay? But they are also play a role. Different lipids do play important structural and functional roles. They're not just reserves that your body's going to store as fat. That's only one thing. So we'll just call it energy reserves. So I'm going to talk about lipids, dietary lipids. All right, so the main dietary lipid that we want to talk about, I need to narrow it down, and those are triglycerides. So my question is not going to be what are lipids, that's too vague. My question is going to be, what are triglycerides? What are triglycerides? So most of our so-called dairy, or dietary, not dairy, most of our so-called dietary fats are triglycerides. So what are triglycerides? So basically, your dietary fats, your dietary lipids are triglycerides. There are also two others, cholesterol and lecithin. We'll talk about those later. Those are totally different things. But typically when we talk about fats, we're talking about triglycerides. Triglycerides are dietary lipids composed of one glycerol plus 3 fatty acids. So these would be the building blocks. Dietary lipids are triglycerides. So triglycerides are dietary lipids composed of one glycerol molecule plus 3 fatty acids. That's indicated by the name triglyceride. Okay? These are, practically speaking, what we call fats and oils. So triglycerides are dietary lipids, are fats and are oils that consist of one glycerol molecule plus 3 fatty acids. And these fatty acids can be quite long. Okay? So that is the answer to that question. What are triglycerides? Or what are dietary fibers? Dietary lipids, they're triglycerides. There are 2 types, and this is where fats can become confusing. Okay? There are 2 types, saturated and unsaturated. Too many T's. I hate writing on the blackboard. But anyway. So we have saturated and unsaturated. Then it gets more confusing. There's mono, unsaturated, and poly. Unsaturated. And so there's good fats and bad fats as far as your diet goes, isn't there? Which one's which? And then there's a third type that kind of fits with this unsaturated. And these are called trans fats. Trans fats are a big dietary no-no. Okay? Most of these are commercially produced oils and fats for frying. Okay? And these are artificially unsaturated. So they've been altered chemically. Well, that doesn't work very well because your body breaks things down with chemical reactions. So if you change the way a molecule is put together, you're going to change how the body processes it. And this is a bad change. And the reason for trans fats, how many have ever heard of, I don't know how many people still use it, Crisco. Crisco, bad, bad, bad. Crisco will last through a nuclear war. Not really, but almost. Crisco is trans fats. It was artificially produced to make a better product. Better in the sense of money, not better in the sense of your health. Okay, it has, I don't know the shelf life. Does it have to be refrigerated? No. It can just sit there for decades? No, I don't know. But the reason that trans fats were commercially produced is because it increases shelf life. And it's cheaper, so we can make more money. Though it is not, at the time, more and more research has been done. At the time that it came out, of course, there was no research on the effects of these artificially altered fats called trans fats. Now, there are some trans fats that do occur in naturally, but not very much. And so there was a big deal about trans fats not that long ago, so now we renamed it. You won't see trans fat on the label because it's already got a bad reputation. You'll see this. So one thing to look for in your label is high fructose corn syrup. Another thing now to look for on your label is partially hydrogenated oils. That is code for trans fat. Partially hydrogenated oils. Trans fats. So what in the world is a trans fat? Well, I kind of need to explain to you the difference between saturated and unsaturated, monosaturated and polyunsaturated. Okay? Basically, with a lipid, you're going to have your glycerol molecule, and then you're going to have chains of fatty acids. Fatty acids are nothing more than long chains of carbon and hydrogen. Okay? Carbon is a very important element. It always forms 4 bonds. It's the basis of organic chemistry. And that's a whole branch of chemistry that you can study carbon compounds the rest of your life. Not what we're going to do here, but saturated means that in my chain of carbons, in my fatty acids, they're all single bonds. Dot, 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 going forever. So that means if they're all single bonds, all the carbons have to have 4 bonds. So it will be completely full of hydrogen in every available spot. So it's called saturated. This is a saturated fats, little portion of its fatty acid chain. That's a saturated fat. It has all of the possible hydrogen bonds filled. Okay? See how it's saturated? All of the carbon slots, all of the hydrogen slots are open and available and attached to a hydrogen. Unsaturated means, let me show you a monounsaturated. Monounsaturated means that we still have our long carbon chain, dot, 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 but there's one double bond between 2 of the carbon. Mono. So what happens to the available hydrogen slots? A little organic chemistry. I know it's early, but you need to understand a little bit. Okay. This guy only is allowed 4. How many are left? 1. So we're missing a hydrogen, aren't we? That's why it's unsaturated. This guy already has 3 also. So he's also missing a hydrogen. So I have 2 missing hydrogen slots because I have an extra carbon bond. That's a monounsaturated. 1 double carbon bond makes us lose 2 hydrogens. So it's no longer completely saturated. It's now called monounsaturated. Poly would happen if I have more double bonds involved, so I'd be losing more hydrogen slots. That's a polyunsaturated lipid, triglyceride. More than one double. All right? So you'll notice that I had all the bottom slots emptied. See that? But that's because naturally occurring polyunsaturated fats structurally look like this. But when I artificially rearrange this molecule so that I can get my hydrogen back, what happens is I end up with, I'm going to break this bond so I get extra hydrogens. And what happens is, in the processing, instead of my hydrogen coming where it would normally be, like this, it will come across. So let me show you. So normally I'm going to get a configuration like this with my carbon bonds. If I want to form it and re-break it, which is what they have to do because we still want it to be unsaturated, that extra hydrogen, this is natural, that extra hydrogen is going to be a problem. It's going to come back over here instead of over here. So where's the hydrogen? Instead of being next to each other in the molecule like it's supposed to be, it ends up being trans, the molecule. So this is a trans fat. It's an artificially produced polyunsaturated. Okay? And what they do, they don't take, here's what they do. Here's our normal unsaturated setup and our trans fat setup. Literally, see how it goes across? This is a trans fat. Because what they do is they don't take a naturally occurring unsaturated fat. They take a saturated fat to make this. They don't make it from here. They don't break it and put it back. What they do is they take an unsaturated fat and they force, here's my unsaturated fat, they force one of the carbons to form that double bond, and instead of it losing both of these, it'll lose one of these and retain this. So it's artificially produced. Artificially produced means what? Bad for you dietarily. Artificial sweeteners are commercially produced. They're made in the laboratory. Your body can't process them the same way it does normal sweeteners, so they need to be avoided. Artificial, dietarily speaking, equals bad. Avoid it. Okay? Yes? Do you have a question?
Could like processed honey and stuff like that?
I'm not talking about processing in the fact that it's purified and homogenized. They may also, I don't know what they do with honey. They might boil it or raise it to a certain temperature to kill bacteria. I'm not talking about that. I'm talking about manufacturing new molecules, artificial. Now, even some of our processed sugars, they're getting bleached and so forth. That's not a good idea either, but I guess we want to have white sugar. Same with flour. It's bleached, different. So that's, processing is kind of vague. Homogenized milk. Okay, we do a lot of processing to increase shelf life and to cut back on salmonella and other foodborne illnesses. I'm not talking about that. I'm talking about artificially produced and rearranged molecules, and the sole purpose is to make it sweeter or make it last longer on the shelf or make it cheaper. Okay, so cheaper isn't necessarily good, especially not in diets. All right, so those are your dietary lipids. So when we have fats, we want to avoid the partially hydrogenated oils, which is the code name for trans fats. Those are artificially unsaturated because we do want to eat more of these. They're better for us as far as contributing to our cholesterol. We've heard of that. And how your body processes, of course, depends different people, but when we're dealing with fats, we want to watch what we eat, not only quantity-wise, but what we eat, both how much we eat and what we eat. So the best fat to use is the monounsaturated. Monounsaturated oils include the olive oils, and peanut oil is not as good, but if you're going to use cooking oil, the best is olive oil. Then the polyunsaturated, also better than the saturated, includes fish oils, sunflower oil, safflower oil, and the corn oils. Corn oils are kind of not good. They're okay. But if you're going to cook with oil, you want to use olive oil. That's the best. Vegetable oil is a combination of polyunsaturated, corn oil, safflower oil, sunflower oil. It's a combination. Your saturated fats include fats found in meats, dairy products, eggs. It also includes coconut oil and palm oil. So the fat that you would eat would be what you find in meat and dairy products and eggs. All right, so on your label, avoid partially hydrogenated oils. These are commercially produced oils that are artificially, right here, artificially unsaturated, which results in the hydrogen being across the molecule in the wrong position. So if the molecule is changed chemically, your body's going to process it differently. Okay? And that can cause various problems. Some ideas about trans fats real quick. There is no known health benefit to the trans fats. Their purpose was commercial profit, cheaper and longer shelf life. Now, there's nothing wrong with trying to have a better product and a cheaper product and longer shelf life. Depends on how you do it. So there's no known health benefit. Trans fats, regardless of origin, have no health benefit. A second idea with the trans fats is that there is potential health risk, particularly coronary heart disease as you get older. Okay? Oh, you know where a lot of your trans fats show up? In the French fryer. Though I think McDonald's now has no trans fats in their French fry oil or whatever, so you want to cut down on the fast food. Another place it shows up, snack foods, fried foods, baked goods. Because they want it to last longer and they want to make it cheaper. It's business. But got to watch what you eat. The potential health risk is coronary heart disease, weight gain, possibly type 2 diabetes. What is type 2 diabetes? Sometimes it's called non-insulin dependent. This is associated with aging and obesity, and what it is you still have your insulin, but your cells become resistant to your own insulin, and so they're not uptaking the glucose, so you have high blood sugar. A lot of times that will be treated with diet, losing weight, and so forth. The mechanism is not very well understood, but what does happen is LDL, HDL, the so-called good fats and the bad fats. And you want a good balance of them. So what happens is it's going to upset your fat balance when you have too many of these. So that is your dietary lipids. The other two are called cholesterol and lecithin. Most of them are your triglycerides, the main one. The other is cholesterol. You have to have cholesterol. It's not all bad. As you get older, you'll probably have your blood cholesterol checked. And then lecithin. Lecithin is a phospholipid. Both of these are important structurally. Probably heard the term steroid. Steroids are naturally occurring in your body all the time. I'm not talking about steroids that they will inject in you for a medical purpose, but steroids need cholesterol and so forth. So cholesterol is a steroid used by the body to make hormones. So I mentioned that hormones are protein, but it's protein with lipid. And these are only found in animal sources. Lecithin is a phospholipid, and it's very important for cell health. And the main source of lecithin is egg yolks. So egg yolks actually are decent to eat. All right. Vitamins and minerals will be next. I'm going to just very briefly go through them. All right, so we will have to finish that.